In this lesson, we'll talk about abstract classes with Java. So as we move from subclass to superclass, classes will naturally become more general and less specific. Superclasses should contain only the common features, right? So as you move up the class hierarchy far enough, a superclass may become so abstract that it can't be instantiated. When that happens, we call it an abstract class. So let's try to understand that with an example. In previous lessons, we had the notion of a geometric object and had two subclasses called circle and rectangle, right? So the geometric object was a superclass, and we had two subclasses, circle and rectangle. Now both circle and rectangle have the notion of an area and notion of a perimeter, right? So, and get area and get perimeter methods. And since all geometric objects have the notion of area and notion of a perimeter, it is better to have those methods in the superclass, in geometric object. But the problem is they can't really be defined there, right? They belong there, but they can't be defined there because the area of a circle is very different from the area of a rectangle, all right? Same with perimeter. So they need to be defined or declared in geometric object, but really implemented in circle or rectangle, right? So a method that is in such a way that it can only be declared somewhere, it's called an abstract method, and the class containing it will have to be an abstract class, right? So let's take a look at that of how it might look like in UML, right? So for this case, we have a geometric object, which is a superclass, and two subclasses. As we spoke earlier, get area and get perimeter, they are belong in geometric object, but they can be defined there, so they're abstract, and it's represented with italics in UML, right? And since these are abstract, the whole class must be abstract, and so geometric object is also represented in italics there, right? There is, you'll notice the pound sign here, which represents protected methods. We'll get to that in a bit, right? So let's look at what this might look like in code. In code, it would look as follows. You have the superclass geometric object, and you have two subclasses, circle and rectangle, that extend geometric object. Right. Now, geometric object has two methods that are abstract, get area and get perimeter, that are declared here, but are not defined. There's no body there, right? And these are also abstract because there is no definition. And since these are abstract, the enclosing class must also be abstract. So we have that here. The subclasses must implement these, must give definition to get area and get perimeter, right? So I've shown get area here. The other thing to note is the constructor should be protected in this case because it can only be used by subclasses, right? So the geometric object as it stands cannot be instantiated, right? It must be extended before it can be used. So you can't use a new operator to create something of type geometric object. Now let's talk about how we will use abstract methods. So we can do that with an example, and our example here is a main class, right, that has a main method, and then has another method called equal area, right? So in the main method, it's instantiating two geometric objects, one with a circle constructor, the other one with a rectangle constructor, and it's passing it into equal area, and within equal area, it's using get area method for both objects and comparing the areas and returning the result. But something very interesting is happening, right? So notice that obj1 and obj2 are of type geometric object, right? Which is very clear. They're declared as such, and they're passed in. Now within equal area, we're using get area for methods for each of them. Now, the get area here that is being invoked is the one that's defined in circle, and the one here is the one defined in rectangle. Now you're asking, how could this be happening, right? And the reason is a concept from a previous lesson called dynamic binding, where JVM basically walks up the class hierarchy and finds the most specific implementation of that method and uses that, right? So this is a very interesting way where you can compare the areas of two very different type of objects, right? Using abstract methods and dynamic binding. This is a big advantage of abstract class and abstract methods. Okay, let's talk about some of the finer points of using abstract classes. So let's take them one at a time, right? So the first one, if a subclass does not implement all abstract method, it must also be abstract. So what does that mean is that, even if you took geometric object and you had a subclass circle, and circle had some abstract methods, circle must itself be abstract, right? That's fairly natural to understand. Now, abstract classes can define constructors, which are called by constructors of subclasses, right? Geometric object had a constructor, and that constructor is the default constructor, will be called by the subclasses, right? Also fairly natural. Okay, we can have abstract classes without any abstract method. So what does that mean? So you can have a class, you can decide to make circle that has implemented all of its method. It doesn't contain any abstract method. You can decide to make it abstract, right? And for some reason in your class design, you might decide to do that. You might decide to have a base class that you want to force people to use, and you want people to subclass from it, right? That is perfectly legal. Okay, next one. A subclass can override methods to make them abstract, right? So you can take a method that was defined in a superclass, it had a definition, but you can decide to make it abstract. Now, why would you do that? Sometimes it happens that a method has meaning in a superclass, but then becomes invalid in the subclass. So you can decide to make it abstract to invalidate it, right? That's one use case. Next one. A subclass can be abstract. Example is geometric object is abstract in our use case, even if its superclass is concrete. So all objects in Java, extend object, right? So object is a concrete class that everything is a subclass of. So geometric is a subclass of. So geometric object is abstract, even though its superclass was concrete. That's perfectly legal, right? Lastly, abstract classes can be used as data types, right? For variable declaration, for parameter passing and such that. And we have seen that. We have seen that in the above method where we use geometric object in declaring and as parameter data types, even though geometric object is abstract. Okay. Okay, next we will try out some examples because this gets quite confusing with all the different variations you have. So we will try that with an example, right? So we will have different definitions of a superclass that, with an abstract method inside it. So A is our superclass, which has an abstract method inside it. And then what we will do is we will have a subclass B that extends A. Then it gives definition to the abstract class. And then we have a main method with inside the main class, which all it does, it instantiates a variable of type B, right? To exercise the hierarchy, right? Because B extends A, right? So we'll fire up IntelliJ and try each one at a time. So we have our main class with the main method here, and then we have our subclass with the definition of unfinished. Now we'll cut and paste each of the definitions of class A one at a time and see what's up. Now here currently A is red here because it has no definition. So let's take this thing one at a time. So we're gonna copy this and we'll paste it here. So let's see what's doing and what's wrong. So you notice that this is red. There's a couple of problems. Well, this first problem is that this thing has a definition, right? If it's abstract, why does it have a definition? It should not have a definition. Second is, if this is abstract, the class must be abstract, right? So, which is also a problem. So let's see what message it gives us, right? So here, it says A is not abstract and does not overwrite an abstract method unfinished, right? And abstract methods cannot have a body. So it's giving you both of the problems with it. All right, let's try out the next example. So this one looks better, right? And it seems to have fixed some of the problems. It's gotten rid of the body. It put the abstract there. Let's run it. It looks all nice, and it in fact everything is good, right? So let's try out the next example. Now here, you're kind of seeing it's very similar to the first example. We don't have a body anymore, so this is a good definition of an abstract method. But this doesn't seem to be abstract. The class needs to be abstract, and that's probably what it's going to complain about. It's going to be that, hey, you need to be abstract. Okay, let's move on to the next one. Here, let's see what's going on. It's got this whole thing red. This is protect. Let's see what's going on. It's not implemented, but it's declared protected. It's a hodgepodge of stuff going on. But let's see what messages it gives us. It gives us missing method body. If it's protected, you're not saying it's abstract, so you're missing the body, right? And then you're saying you can't override unfinished in B. It is all kind of it's missing the body there anyway, right? So it is not a proper definition here, so you're trying to override something that is not proper in the first place. Okay, let's go to the next one. Here, let's see. Let's see what's going on here. The obvious thing here is that abstract is in the wrong place, right? And it really, all the modifiers need to be before that, right? It needs to be up here. Abstract needs to be right in the beginning, right? That's the problem. It's giving you a whole bunch of problems with it because the code doesn't make any sense. It's having parsing issues, so it's got 10 issues. It's not even buildable. Okay, get rid of that one. And lastly, we've got this one. That's an interesting one. Let's see what's wrong with that one. It looks kind of right. So the interesting thing here is that looks right, but the type is wrong. Here you have int, and you're defining it with void, so that's a problem, and hopefully that's what's going to show. I mean, the message is not very clear, right? But the issue is it's thinking of this unfinished and that unfinished as two different things because they have two different signatures, right? So that's why you're getting this message. And if you were debugging this, you'd say, what's going on? But that's the problem here. All right, so that has been a lesson on abstract classes and abstract methods, a very interesting topic.